वेलकम बैक टू माय डियर फ्रेंड्स टू द टेक सिविल लर्निंग। आप सभी को टेक सिविल लर्निंग में स्वागत है। इफ़ यू हैव नॉट सब्सक्राइब माय चैनल प्लीज़ सब्सक्राइब इट सो दैट once I upload the video you will get the notifications. As I promised, I will provide you quality and practicals educations, because being practicals is my motto. So I used to connect every theoretical concept to the practical levels. So that is what today we will going to discuss about. In the today especially we will discuss about the moment of resistance. So let's start the series. So please subscribe it and let's enjoy our lecture. Okay, moment of resistance. My dear friend, as I used to told you every day that connect it to the practical level. Moment of resistance is nothing but we can define it as the resistance which is offered by the beam, which is given by the beam, right, to resist of the bending. जो bending को resist करने के लिए एक internal force होता है उसी को बोलता है moment of resistance. और we can define it as a couple produced by the internal forces in the beam which is subjected to bending under the maximum permissible stress, right? And lots of students have doubt of the couples. My dear friends, let's take few example of couple. Couple is nothing but the equal and parallel having the same magnitude but opposite in directions. This is nothing but the couples. Examples: opening of water bottle. While you open the water bottle, we apply equal and parallel forces of having the same magnitude but opposite in direction. Similarly, opening of knots. These are the examples of the couples. So in this series we discuss about the moment of resistance of the different sections like balance section, under reinforcement sections and over reinforcement section. हम लोग बैलेंस सेक्शंस, अंडर रिइंफोर्स्ड सेक्शंस एंड ओवर रिइंफोर्स्ड सेक्शन इसके बारे में पहले भी पहला लेक्चर में देख चुके. वी हैव ऑलरेडी डिस्कस अबाउट ऑल दिस थ्री सेक्शंस. सो इफ यू हैव नॉट वॉच दैट वीडियो प्लीज गो थ्रू दैट वन सो दैट यू कैन अंडरस्टैंड क्लियरली अबाउट इट, because I have given the best explanation of the different types of sections. So please go and watch that video so that you can understand clearly. So let's start the moment of resistance for the balance section. So my dear friends, if you have watched the previous video clearly, I have explained about the balance sections. Let me tell you once again. This is a type of sections in which a maximum compressive stress of concrete and maximum tensile stress of what steels approaches permissible value at the same times. Means both approaches their permissible value at the same times. Let's take the examples once again so that you can understand clearly, because I believe in quality and practical education. Suppose we have rectangular beam, right? Sorry, wait. Here we have drawn a rectangular beam. The uppermost portion is subjected to the compressive. Why? As I have explained you in the previous video, and the top and the bottom fiber is subjected to tensile stress, right? So the balance section, suppose this one's compressive stress approaches its maximum permissible value is 50 kilonewton. Suppose this one is 50 kilonewton per meter, then the maximum tensile stress is also 50. This is nothing but the balance sections, means both the sections are balanced. So here I have taken one rectangular beam in which a bar is inserted in the concrete, and the having a width of the beam is B and the effective depth of the beam is D. Overall depth will be D. Overall depth is nothing but the effective depth plus clear cover. Now here the technical term calls clear cover. So let's understand it practically. Let me show you one figure so that you can understand it. My dear friends, this is column, right? So column, we can see that here means the extra portions, right, means the portion which is exposed to the atmospheric to the to the bar, right? Here the some extra portions are to be constructed, right, means up to here. See, we can see that the bar is inserted after having some minimum gap, right? This portion is nothing but the called clear cover. Clear cover is provided to avoid the steel from the different atmospheric chemical reaction like corrosion. So we have to give some extra clear cover of the concrete. So clear cover is nothing but we can define it in your own way once you know the concept of clear cover. It is the covers and the distance between the concrete which is exposed to the weather, atmospheric weather, टू द बार। जितना कैसा होता है ना कि जो बाहर का सरफेस जो होता है उधर से लेके जहाँ पे रॉड तक का जो डिस्टेंस होता है, जो एक्स्ट्रा डिस्टेंस होता है, ठीक है, एक्स्ट्रा पोर्शन जो प्रोवाइड किया जाता है कंक्रीट को, उसी को क्लियर कवर बोला जाता है। ठीक है, तो इस डायग्राम में भी इधर जो है इधर से लेके इधर तक क्लियर कवर है। ठीक है, फ्रॉम हेयर टू हेयर, राइट, हेयर द क्लियर कवर आई हैव गिवन, लेट्स एज्यूम 25 mm. Here the stress diagram, as we know the stress at the neutral axis is 0, so when you move to the topmost fiber the stress increases, either the compressive or the tensile. So the here the topmost fiber consists of maximum tensile stress. Similarly the means resultant tensile stress will be the sigma cbc by 2 into b into x, where the z is nothing but the z is called lever arm, and here the j equal lever arm constant. So let's derive the formula for the moment of resistance of the bilateral section. Hope आपको moment of resistance clear हुआ होगा. Moment of resistance having the material having more moment of resistance, it's very difficult to deform or it's very difficult to bend. Arm, lever arm is nothing but the resultant compressive force and the resultant tensile force. The distance between the resultant compressive force and the resultant tensile force is nothing but called the lever arm. As we have seen that the compressive area is triangular formation. Here you can see that it is a triangular formation. So we know if you need to find here the resultant compressive force, resultant compressive force is nothing but the stress into area. Here the maximum stress is sigma cbc and area of the any triangle is half base into height. The half base is nothing but the b and the means h is the depth of neutral axis. As you can see that the b overall width is b and the h and the x is the means neutral axis depth, the distance from topmost fiber to the neutral axis, that is nothing but the x. In the same manner tensile force is nothing but the tensile stress of steel into the area of steel, that is sigma st into as. As is nothing but the area of steel. So let's see here lever arm is as I have explained the means resultant compressive stress of concrete and the resultant compressive stress of tensile. So lever arm z is indicated as z and it is equal to d minus x by 3. This is so because let me tell you one figure so that you can understand. Here z we can find at the d total over means effective depth minus these portions x by 3. So means lever arm is z is equal to that is effective depth here to here effective depth minus this one x by 3. We can also write it as n by 3, notation depends upon you. So z is x means d minus x by 3. So hope you understand. Similarly here d minus x by 3, here d is same minus x is nothing but the depth of neutral axis, and here we can write it x is equal to k into d. This is how we know the k is neutral axis constant and d is depth, effective depth. So x can be written as, so we can write x is equal to nothing but k into, that is k into d. Here k is nothing but the neutral axis constant and d is effective depth of the beam. Similarly if you take common of the d, here d and d, so d commons, then it remains 1 minus k by 3 and that is d is, and this 1 minus k by 3 is written as j, where j is lever constant. So lever arm is equal to d into j, where j is considered as the lever constant. So these are the means design constants. Now takes the moment of resistance. Here the moment of resistance, as I told you, the moment of resistance is nothing but the force into distance, right? So here there are two kinds of force, that is compressive force from the topmost fiber and the tensile force from the bottommost fiber. So compressive force, so let's calculate. We have already calculated the above, the compressive force, that is sigma cbc by 2 into b into x, right, where the z is equal to d minus x by 3. Now here 1 by 2 sigma CBT, this B is written as B, X is written as X. Here instead of X we have written K into D. Similarly instead of X we will put K into D, where K is neutral axis constant. जो K का वैल्यू है वो न्यूट्रल एक्सिस कंस्टेंट है. हम लोग K का वैल्यू पहले भी डिराइव कर चुके हैं. वी हैव ऑलरेडी डिराइव्ड द वैल्यू ऑफ K in the previous lectures. So it's my request to follow my lecture so that you can understand the concept clearly. We have already derived the value of K. So X is equal to K into D. Here D K minus means D minus K into D by 3. Here we have again taken D as a common, so it becomes B into D square. D into D, D square, K 1 minus K by 3. Similarly, then it can be written as 1 by 2 sigma CBC BD square, K, this one minus K by 3 is written as J, where J is lever constant. So this term from here to here, it can be written as what? It can be written as Q. So we can write Q into BD square. This one 1 by 2 sigma CBC K into J can be written as Q, and this one BD square is BD square. So moment of resistance is equal to ultimately 1 by 2 sigma CBC into K into J into BD square. So this is the moment of resistance for the balanced beam. Similarly, moment of resistance for the tensile sections, right? So it's very easy. Tensile force into area. The tensile force is nothing but the stress into area, the sigma ST into area. Similarly, Z can be written as D minus X by 3. Again we will substitute X is equal to what? X is equal to, we know, K into D by 3. Similarly, sigma ST, we will take the D as a common, so D take it out, 1 minus K by 3. Then we can write it ultimately sigma ST into AST into JD. Here if you need to find the area of steel, then we can just substitute these two value into this one. So MR by sigma ST into J into D is the to calculate the area of the steel. So hope you understand how to derive the formula for the moment of resistance of the balanced sections, as I have already explained the balanced section in the previous video. So my dear friends, believe in quality education, the practical education. Hope you understand this concept very clearly. There is no doubt. If you have any doubt, just put your comment in the comment box. अगर आप लोगों का कुछ भी डाउट है, then comment box में लिखिए. I promise I will solve that doubt. Keep supporting and keep loving, so that I will try to my best levels. I will give you all the information what I know. So let's see the different section. Same manners, we will talk about the moment of resistance for the under reinforced sections. Many times I have told you, please follow my channel from the beginning so that you can understand. Under reinforcement section is nothing but the type of sections in which the percentage of steel is less. In this type of sections, the fracture or the failure always takes from the tensile zone, because the capacity of steel is fully stressed, whereas the concrete is not reaching the maximum value. I have given the few example in the previous video, so that let's understand the directly moment of resistance. If you have not gone through the previous video, please go and watch the reinforcement section. You can understand very clearly, because I have explained the best way. So here, because of having the less percentage of steel, what happens, the neutral जो actual axis होता है, actual neutral axis, वो upward means shift हो जाता है. Then upward shift होने के बाद the distance between topmost fiber to the neutral axis is x square. Similarly, the distance between topmost fiber to the critical neutral axis is xc. Here, as I told you that in the under reinforcement sections, the failure always takes from the concrete. The failure always takes from the steel, and the type of failure is ductility failure, because here the steel is fully stressed. Here you can see that this one's the axis which is passing from actual neutral axis here cannot utilize the full maximum stress, right? The maximum stress of the maximum compressive stress of the concrete is sigma CBC up to here, but what happens, because of having less percentage of steel, the neutral axis shifted upwards, but so that in the under reinforcement section the fully maximum compressive stress of concrete cannot be utilized, so that failure always takes from the steel. Here the XA, that is the actual neutral axis, is smaller than actual critical neutral axis. So let's see. As we know, in this type of section the failure always takes in the steel side, that is in the tensile side. So here we will again calculate the moment of resistance in the tensile zone. Here the tensile force into Z. Z is lever arm. Lever arm is the resultant compressive stress of concrete and the resultant tensile stress of steel. Here the tensile force is nothing but the stress into area, sigma st into ast, where z is written as d minus x by 3 as previous we have written. So पहले के जैसा है, कुछ भी टेंशन लेने का टेंशन नहीं, बस आप लोग समझिए, समझ के पढ़िए, मुझे अच्छा लगेगा. I feel happy when you understand the concept. So please put in comment box that you have understand the concept, because it encourages me a lot. So sigma est minus into ast. Here dx can be written as k dash into d. Here notation I have given, the constant neutral axis is k dash into d. Again we will take d as a common, so ultimately 1 minus k dash by 3. Here the sigma est into ast into d dash into j dash. Here I will write this term, whole term as what, j dash. So I have written here j dash. So let's see next. Now here we have to calculate area of steel, right? So the area of steel can be calculated as A means percentage of steel P is equal to AS into 100 by B into D, where B is breadth of beam and D is effective depth. So AST is equal to that one. This AST can be written as P into B into D by 100. So the area of steel is nothing but the P into B into D by 100. So moment of resistance can be ultimately written as sigma est. Substitute this value here, ast by ast into d into j. Then ast can be written as P into B into D by 100 into J dash into 100. So eventually we can write it as sigma est P into J by 100 into BD square, and these ones can be written as, this equation can be written as Q. So Q is Q into BD square. So this is the moment of resistance for the under reinforcement sections. As we know, under reinforcement section is superseded of over reinforcement sections, because designers mostly preferred these type of sections because of the many criteria, right? इसका अंडर reinforcement डिजाइन के लिए बेस्ट होता है, ठीक है. अब क्यों होता है, मैंने पहले वाला वीडियो में ऑलरेडी एक्सप्लेन कर चुका हूँ बहुत अच्छे तरीका से, विथ अलॉन्ग विद द प्रॉपर नोट. सो लेट्स सी द नेक्स्ट वीडियो. नेक्स्ट here the over reinforcement section. Over reinforcement section is quite opposite of the under reinforcement sections, just उसका उल्टा होता है. In this type of section the percentage of steel usage is high, right? It means more number percentage of steel is used. So we can say that suppose this one is a rectangular beam, right? In this section this one is subjected to in the tensile zone we have inserted the bar. So here the percentage of steel is the bar is inserted more, right? More number of bar is inserted in this zone. So here the tensile stress capacity is more, here if in tensile zone it is 70 kilonewton per meter square, then in concrete zone it may be only 50 kilonewton. So the concrete or so the structures always fell from the this side, right? Always fell from the concrete. Sudden failure will always takes place this side. So because of having sudden failures and uneconomical, because the more number of or more percentage of steel is used, so over reinforcement section is neglected in the design steps. So here we can say that the compressive stress of concrete is fully cross its limits value. At the same times the sigma est by m, that is maximum tensile stress of steel, cannot be utilized. So this type of sections always fell from concrete side, that is compressive side. So the moment of resistance of such sections will be governed by the compressive strength of the concrete. So my dear friends, this one is also quite similar to the previous one. So here we will calculate the moment of resistance for the over reinforcement sections. Here the 1/2 sigma CBC B into XA D minus XA by 3, as it is taken from the, this one is compressive force into, that is lever, what, arm lever. So sigma CBC by 2 into B into XA, here X can be written, XA can be written as, here this XA can be written as K dash by D dash. Similarly, this XA can be also written as the same K into B dash. So sigma CBT XA B into D, here D taken a common, then sigma C B XA DJ, it can be written as. So here sigma CBC by 2 B into D XA into J, here this term is written as J, 1 minus K dash by 3. So 1/2 sigma CBC K dash D dash into J, so 1 minus CBC K dash D dash and B into D square. If we substitute, if the in the instead of XA we can write what, K into D, so D into D, D square, so 1/2 sigma CBC KD, and these terms can be written as this up to here, this term can be written as Q, so Q dash BD square. So this is the formula for the moment of resistance of the different sections. Hope you understand. If you have any doubt, please put in the comment. If you have any, if you want to say anything that where I am declining or where I cannot understand you, so that I can understand and I can provide you the clear note. अगर आप लोग कुछ भी समझ में नहीं आता है देन कमेंट बॉक्स में लिखिए ताकि मुझे पता चले. प्रॉमिस करता हूँ, ठीक है, आपको समझ में आया होगा. अगर नहीं समझ में आया देन फिर से बताइए. सो होप you understand the moment of resistance for the different sections. So let's see some numerical problems. My dear friends, if you understand this concept clearly, then it's very easy to solve the problems. Here let's see design first. Before solving any numerical problems, what I believe is to visualize the numerical things, because numerical is very interesting. If you know the theoretical concept, we can solve the numerical value easily. So understand what here said मीन्स एक ऐसा डिज़ाइन कीजिए रेक्टेंगल बीम का, एक रेक्टेंगल बीम को डिज़ाइन कीजिए जो रेसिस्ट करेगा बेंडिंग मोमेंट 200 किलो न्यूटन मीटर, जिसका विड्थ बीम है 450 mm, यूज M20 कंक्रीट ग्रेड. हेयर एज द डिजाइनर सेड यूज M20 मीन्स कंक्रीट. M20 रेशियो इज 1:1.5:3, where the maximum stress of concrete is given as 7 Newton per mm square. At the same time, use the mild steels and use the high deform bar and design a rectangular beam. Here the question said is, as an engineer we must have to design a safe structures. So here we need to design a, means we have to design a rectangular beam. Here the width is given. So first of all we need to follow some steps. So here in first steps calculate the design constant. My dear friends, we know the design, what are the design constants. I have given one lectures based on the design concept. So मैं तो यही बोलूँगा, अगर नहीं देखे तो जाके देख लीजिए ताकि आपको समझ में आसानी हो जाए, आपको समझने में आसानी हो जाए. अगर आपको पता है देन कोई प्रॉब्लम नहीं है. So let's calculate the first design constant. So before constant, calculate the moment modular ratio. Modular ratio is ES by EC. So the modular ratio is given by 280/3 into sigma CBC. It is given by the designer. It is the constant value which is given by the designer for the safe structure. So we have to adopt all these things. ये designer ने बहुत एक्सपेरिमेंट करने के बाद ये फॉर्मूला दिया है. सो दिस वंस इज यूज फॉर द सेफ स्ट्रक्चर्स फॉर द मॉडुलर रेशियो. अब आप सोच रहे हो व्हाई वी नीड टू कैलकुलेट m, because while calculating the design constant k j we need the value of m. So in order to know the value of m we must have to calculate the modular ratio. So modular ratio finally came 13.33. Now for the mild steel, here in the question it is given mild steel and high deform bar. For the mild steel, neutral axis constant, the formula 1/1 plus sigma st by m into sigma cbc. We have already derived this formula in the lecture 1 I think. So if you have not watched, I will put that one in the video, or I will put that link in the description box so that you can find it easily. So here if you substitute sigma est value is given, you can see that sigma est value is given here, sigma est value is given. So substitute all this value in the formula, you will get. So sigma est value is 140. Similarly, we have already calculated modular ratio m 13.33 and sigma maximum compressive strength of concrete is given as 7. So it finally neutral axis constant came 0.4. Now next lever arm constant, that is 1 minus k by 3. We have right now we have derived the formula. So 1 minus k value is 0.4 by 3, so 0.87. Now we have already calculated the means design constant. So let's calculate moment of resistance. Moment of resistance constant, because we need to calculate moment of resistance. So moment of resistance constant Q is equal to 1 by sigma CBC into K into J. If you substitute all those value, the moment of resistance for the constants came. Now we have already calculated the design constant. Now second steps we need to adopt is determine the critical moment resistance. अब सेकेंड स्टेप में हम लोग को क्रिटिकल मोमेंट रेसिस्टेंस निकालना है, एम आर. We know the formula of mr, q into bd square, right? Here the mr is given 200 kilonewton per meter. If you change the kilonewton into newtons, then 10 to the power 3. Similarly, meter into mm, then 10 to the power 3. So that's why 200 into 1000 into 1000. Here in newton, here in mm. We have already all this value where d is need to be calculated because width is already given. So यहाँ पे d निकालना है. So if you substitute, if you put all this value this sides, then d value come 606. My dear friends, मैं एक चीज़ यहाँ पे बोलना चाहता हूँ. यहाँ पे जो 606 आया वो ठीक है, effective depth है, ठीक है, and width is 450. So what happens? Let me tell you, कोई भी बीम जब आप डिजाइन कीजिएगा, ध्यान से सुनिए. If you design any beam, if the beam of having the more depth is considered as the more stability and strong. समझ में आया? जिस बीम का डेप्थ जितना ज़्यादा होता है वो उतना स्ट्रॉन्ग होता है. अगर नहीं समझ में आया तो चलिए एक प्रैक्टिकल एग्जांपल से आपको मैं समझाता हूँ. लेट्स सी वन प्रैक्टिकल एग्जांपल, यू विल गेट इट इजीली. सो लेट्स सी माय फ्रेंड. As I said, the more depth of the beam increases its durability and load bearing capacity. So imagine I have taken one scale, simple scales of, imagine this scale is a beam. So I kept it such that the means the depth of the scale is more. So if I tends to bend it, if I try to bend it, अगर मैं इसको bend करना चाहूँ जबकि इसको मैं डेप्थ का साइड ज़्यादा दिया हूँ, ठीक है, एकदम मतलब इसको एकदम वर्टिकली पकड़ा हूँ और उसको मैं बेंड कर रहा हूँ, ठीक है, आप देख सकते हैं इमेज में. सो दैट आई डिड एक्सपेरिमेंट्स इजिली. if I try to bend it, then it's very difficult to bend it. You can also try it one, but once this one's thickness, right, thickness, this one depth is, I have just did the opposite, right, I have increased its width. Here you can see that the width of the beam is more, but the depth of the scale is very less, so it can bend easily. At the here the depth is high but the width is very less, although it can withstand a high load bearing capacity. So let me tell you one thing, if you design any structures, keep the depth of the beam is higher to provide safe and high load bearing capacity of the structures. So समझ में आया? So let's say here the diameter of the bar, means bar diameter is not given, so let's assume, as we are engineer we have to assume certain things. So we assume a 20 mm diameter bar we will use for the construction of the or for the design of the beam. So we need to calculate the overall depth. So overall depth is equal to effective depth, that is a small d, plus dia of bar. So 1/2 dia of bar plus covers, right. I have already introduced you what is clear cover, right, means the extra portions which is from the compressive side or which is from the atmospheric side, which is exposed to the atmospheric to the distance to the bar, ठीक है, जो बार तक का डिस्टेंस होता है, बाहर तक का जो एक्स्ट्रा प्रोवाइड किया होता है, ठीक है, उसी को क्लियर कवर बोला जाता है. आपको मैं पहले ही एक फिगर में दिखा दिया हूँ, अगर आपको नहीं पता देन देख लीजिए इधर, ठीक है, इधर जो है ये यही होता है क्लियर कवर, ठीक है, जो एक्स्ट्रा जो है बार से बाहर की तरफ जो एक्स्ट्रा पोर्शन जो कुछ होता है उसी को क्लियर कवर बोला जाता है, राइट. सो हेयर it finally came 641. So as I told you, the beam having more depth is considered as the more strong beam, and I have shown you the practical example. So let's assume I have taken it as the 750. You can take it your own way. You can also take 700, 725, 800. It's depend upon the designer. These value are particularly depend upon the designer. ये जो value होता है वो designer पे depend पड़ता है कितना लेना है. नाउ इफेक्टिव डेप्थ जो करना है वो 750 माइनस 10 माइनस 25, ठीक है, क्योंकि इफेक्टिव डेप्थ भी निकालना है तो 10 माइनस 25 जो पूरा ओवरऑल डेप्थ में से. नाउ वी नीड टू माइनस द बार डाया बिकॉज बार इज हैविंग द सम एरिया, देन माइनस 10 एंड माइनस 25, दैट वन इज 751 is the effective depth. Now we need to calculate area of steel. So previously we have already derived the formula Bm by sigma S T into J. So here the area of steel came. So the area of steel is if 2297 mm square. Now we have to fit how many bar we can insert it in this. So we will insert 8 bars of 20 mm diameter providing 2514 area of the steel, right. So we will provide 8 number of bar in the beam such that it can withstand the load easily. Here you can see here the overall width is B means 450. Here the total depth, overall depth is 750, and if we deduct this clear cover, the distance between the here and the here is nothing but the clear cover. So I have taken clear cover is 25. For any beam, let me tell you one thing, for any beam the clear cover must be greater than 25 mm. Less than 25 mm for the construction of a beam is not to be considered. So 25 I have taken the minimum. So this one 750 minus 25, so 725, and overall width is here, overall width is 450. So here this one also distance, and here also 25, 50, then it will come 8 380, 25 25 380. So these are the designs for the mild steel types of beam. So here there are two types of beam. One is high strength deform bar. Similarly in this one also we will calculate the same things. For design steps K, already I have given you formula J1 minus K by 3. Similarly moment of resistance 1 by 2 sigma CVC K into J. We know the J 1 minus K 1 minus, sorry for inconvenience my dear friends, I am really sorry. Here moment of resistance we will calculate similar same way. Now bending moment as the same way, just the difference is there we used mild steel, here high deform bar is used, just the two types of different bar is used, the process is same. Here also we calculate the D, then we will calculate the overall depth, that is D plus 1 by 2 dia bar plus covers, that is comes 732. As it's depend upon the designers, I have taken it as a 900, then effective depth capital D minus cover minus 1 by 2 dia bar, then that is 865, right. So I have area of steel calculated, then I will provide 4 bars because we can here we know the area of one steel is what, pi by 4 into d square, right, and d is 20 d square, and how many numbers of bar is used into 4, it's depend upon the area 4, then it must come 1 to 5 6. So in 1 to 5 6 we insert 4 bars. So here the area of steel is it's depend upon the designers, ये डिजाइनर पे डिपेंड पड़ता है कि कितना लेना है और उसमें कितना बार रखना है. अगर कोई डिजाइनर को 3 ही बार रखना है, 3 ही बार पे जितना लोड उस पे विथ स्टैंड सेटिस्फाई हो रहा है, देन इट्स डिपेंड अपॉन द टोटली डिपेंड अपॉन द डिजाइनर. सो हियर I have inserted only 4 bars having the 450 overall depth, and the effective depth will minus 25 25, here 25, then it will become 400. Similarly this one is 900, we will minus this 25, 875. So these are I have the designs which is given for the beam. So this is the design for the beam. Now once again see once more interesting numericals. Here we need to find the moment of resistance, right, moment of resistance of the beam, and here the maximum stress of steel and concrete is given. So the maximum steel is for the steel is say 230 Newton per mm square, and that one for the concrete is here one data is missing, my friend. That one, the maximum compressive strength, that is sigma C B C is given equal to 7 in Q, 7 Newton per mm square, right? So here in the figure it is very clearly given that the overall depth of the beam is 450. Here 20 mm of bar is used. There are 8 number of bar, and the clear cover is taken as 35. In the previous video we have taken the clear cover 25, here the 35 is taken, so the overall depth is 750. Now here we will need to calculate, we need to calculate moment of resistance. In moment of resistance, neutral axis is to be needed. So first we calculate the neutral axis. So first let the xa be the neutral depth of neutral axis. For calculate neutral axis, we will take the moment of compressive and the tensile area, and we know 1/2 b into x square into x square a, because it is the x square taken because we need to calculate depth of neutral axis, that is 2 times, one is compressive and one is tensile. So x square, and the means compressive and the tensile area is m into as, and that is this portion is nothing, this portion is nothing, this portion is nothing but d minus x by a, right? So m into as into d minus x by a. So here we can substitute, b value is 450, here x square is kept as the x square, and m value we have already known in the equation, it is given. As we will calculate, and as is also already given in the questions. I think if it is not given, then we have to calculate how to calculate this as value. Hope you understand that I have already told you formula m moment of resistance by sigma CBC into B into J. So from here we will calculate as, so it comes 2514. Similarly D is 750 minus XA, right? Here we can calculate the as by using the formula. Similarly we sub as, if we put all these things to here, and we will do the equation from XA value come to 60.25 mm, 25 mm. Now we will know the moment of resistance is equal to Q dash into B into D square, where Q is 1/2 sigma CBC K dash by J. So by putting all this value, the Q value will come, and if you substitute the all value here I have substitute this one Q value here, and these two value here, then it come moment of resistance is 2.10 into 10 to the power 8. Now my friend, here need to be understand is the sections which we have calculated the moment of resistance is either under reinforcement, over reinforcement, balanced. So we need to know all these things. So for calculating the means actual neutral axis of this, we have to know that the k value into d x8, right? If this value is greater than, if this means this critical value is greater than the actual, then it is what type of sections? I have already told you all these things. If critical axis is greater than neutral axis, then it must be over reinforcement sections, and if the actual neutral axis is greater than criticals, then it must be over, it is vice versa. If the criticals neutral axis is less than the actual neutral axis, then it is under reinforcement section. So calculate and check whether it is under reinforcement or over reinforcement. So similarly, my dear friends, please solve these problems and try to solve these ones. If you cannot, then I will give you the solution of this numerical in the next series. So hope you can solve these ones, because let me check you whether you can solve or not. So at the last, I would like to say that if you have any confusion, please put in the comment box so that I can understand. And if you really like this video, if you really understand the concept, please like, subscribe and hit the bell icons. आप अपना ध्यान रखें, खुश रहिए और टेक केयर, स्टे हैप्पी, बाय बाय।